Hello dear students, welcome back again for solving numerical problems from engineering mechanics for civil engineering students, for mechanical engineering students and students of computer science in some engineering colleges. Problem set 2.4, solution to 2.53. The statement of the problem goes like this. Determine the axial forces S1 and S2 induced in bars AC and BC. AC is a bar, BC is a bar. They are not strings. In figure K, this figure is K as given in your book. Due to action of a horizontal applied load at C. Here, the load is applied at C to this side, 4450 Newton. The bars are hanged together at C. The bar AC and BC, they are hanged together at point C. And to the foundation at A and B. And this is the foundation. AC is hanged here. BC is hanged here. And together they are hanged at C. There is a horizontal force. Remember, these are two bars, not two strings. So why do I say so? So that will help you to find to properly implement the direction of the axial forces. Now, AC and BC are not strings. I repeat, they are not strings. So, due to 4450 Newton towards right, towards this side, the bar AC, due to this force, is under extension. Means this bar AC is trying to extend its length, and the bar CB is under contraction. Due to this force, this bar CB is trying to contract. Now, had this force 4450 Newton been towards left like this, then the opposite would have happened. Means AC would have been under contraction. Had this force been to this side, then AC would have been under contraction and BC would have been under extension. So that is what you have to understand. So therefore, let S1 is the tensile force in AC and S2 is the tensile force in CB. So S1 will be away from the point C, to this side, your S1, and S2, the tensile force developed in the bar BC, will be towards C, S2. That is to be understood. So when something is when a bar is under a contraction, from the point it will be away. If a bar is under if a bar is under extension, this bar which is under extension, the axial force will be away from the point, and if it is under contraction, it will be towards the point. That is to be understood. Then it is simple. Now, let angle CAB is equal to alpha. Angle CAB, this angle, let it be alpha, and let this angle is equal to beta. From this point to this point, the length is given as, height is given as 762 millimeter. From here to here, this is given as 915 millimeter. From here to here, this is given as 6110 millimeter. So if you apply tan alpha and cross multiply, and you will get, and if you take tan beta in this triangle and cross multiply, then you will find alpha and beta. So that is what I am doing. So tan alpha, tan of this angle will be the perpendicular over base, that is equal to 762 over 915. Tan alpha is equal to 762 over 915. So alpha is tan inverse 762 over 915. That comes out to be 39 degree 47 minutes of arc, 13.52. I will not consider this, I will only consider this. Similarly, tan beta from this triangle, which is right angled here, and this triangle is also right angled here, your tan beta will be perpendicular over base, that is 762 over 610, 610. So tan beta is equal to 762 over 610. So beta is tan inverse of this. That comes out to be 51 degree. 19 minute, 18.69 seconds of arc. I will not consider this. I will only consider this. Now let us then draw the free body diagram at point C. At point C, there are three forces. One is this. Here is S1 and here is your S2. So, so the free body diagram, I have at this point I have taken this line as x-axis and this line as y-axis to draw the free body diagram. So your free body diagram looks like this. This is your x-axis, this is your x dash negative x-axis, this is your y-axis, this is your negative y-axis, this is your S1, this is your S2, and this one is the applied force, so weight, load 4450 Newton. Now the question is how this is alpha and this is beta. Now, if you extend this line, of action, since this angle is alpha, so this will also be alpha, alternate angle. So that is what is shown here. Now, similarly, if you extend this, this is beta, this angle is beta, therefore this angle will also be a beta, because this is your x-axis, this is the ground, they are parallel, and this line is the transversal. So this angle is beta, therefore this angle is beta because they are corresponding angles. So I have shown it here. Once that is done, the rest is very simple. Now let us apply sigma y is equal to 0. If you drop a perpendicular from the tip of this axial force on the y-axis, here this will be 90 degree, and this part from O to here will be your S2 sine beta towards positive y-axis. And from here, if you drop a perpendicular here, now, and one from here, and one from here to find out the x and y components. So this part from here to here, that is same thing as this, will be your S1 sin alpha. So S2 sin beta, S1 sin alpha, they are opposite to each other. So if they are equal, then the condition of equilibrium is established. So I have made them equal. Sigma y is equal to 0. So S2 is equal to sin beta comes to this side. So we have already found out alpha and beta. So put the value of alpha and beta. So put it in a scientific calculator. This comes out to be 0.8197 times S1. Now then apply sigma x is equal to 0. The component of this axial force S2 along negative x-axis is from this point to this point. That will be equal to, this will be equal to your S2 cos beta. Similarly, the x component of S1, if you drop a perpendicular, that is from here to here, will be your S1 cos alpha. Both of them are in the negative x-axis, and that is being opposed by P is equal to 4450 Newton. So S1 cos alpha plus S2 cos beta will be 4450 Newton. So S1 cos alpha plus S2 cos beta is equal to P, that is 445 Newton. Now S1 cos, this is your alpha, S2. For S2, which I just calculated S2 as 0.8197 times S1, I substitute here 0.8197 S1, then cos of a beta comes out to be 4450. Now there is S1 here, there is S1 here, when both are multiplied, and here is an addition, so there are two terms. This is one term, this is another term, there is a positive sign, so S1 is taken common, so I am left with cos 39, 47 minutes, 0.8197 cos 51 degree 19 minutes, that is this much. Now to find S1, this whole thing which is multiplied with S1 is taken to the right hand side to be divided. So S1 becomes 4450 over this. So if you put it in a scientific calculator, this comes out to be exactly 3474.404 Newton. So S1 is calculated. Now to find S2, S2 was calculated 0.8197 times S1. Now put the value of S1 which you just calculated here. So your S2 comes out to be 0.8197 times S1. Put the value of S1, put it in a scientific calculator, this comes out to be 2847.969 Newton.